Thanks everyone for coming. My name is Matt Varian. Today I was going to talk about industrial cameras and how they're sort of a overlooked thing just because we don't normally interact with them. So where I first came across these, and here's a couple examples, and we'll go through some more. Most of the time, about like 4 or 5 times a year, I go out to the desert and I operate this camera, which is a very expensive. It's got a mid-wave camera and it's got a high-speed camera. And after probably, I guess, 5 years of that, we started to build our own. So started to go down the path of what goes into camera systems, not just like ones you can buy, but ones you're sort of building up the capabilities for. We started, and so for reference, like that bottom is the mid-wave camera. It's like 7 months to buy. So you pay them a small house and they will send it to you in about a year. So in the meantime though, we still have to develop software. We still want to work on stuff, and so looking at sort of cheaper ways to use some of the same interfaces we were going to see on the big one, but on just a more affordable, quicker to get scale. That's when I started looking at industrial cameras. So what are industrial cameras? They're often, you'll see this form factor. They do come bigger. So this is a big, like I say, a big one. This is the camera, and what you're buying most of the time is just this little bit here. They're normally, this is a C-mount lens. A lot of what I guess security systems use C-mount, a bunch of other things, and so you can buy lenses from all kinds of people. They are sort of separate. Like you don't buy, like you could go buy a Canon and it comes with a lens. You don't get that with these. You buy each piece individually. They're industrial, so they're sort of designed to be on a automation, like a manufacturing floor, just running all the time. You can get them pretty weather resistant. I think IP67's 3 feet submerged for X amount of time, so they're pretty tough. You can get them in all kinds of sensors. So, like these look identical from the outside. They have different sensors in them, and there's a lot of sensors. There's different ways to communicate with them. Like on the back here, you'll see it's just that's a GigE, and that's the most common because you can just run a data line that can power the camera and get your data back. But you can also get them a USB and coax express, camera link, 5 gig, 10 gig. There's 100 gig off the camera sensor. So there's a bunch of options, and as well as just a camera sensor, there's some smarts in there. There's a board that'll you can configure for your levels, various other functions. So there's that, and then they're not a Canon or Nikon. There's a lot of people. They all make very similar ones. They'll buy Sony sensor. They'll put it in their package and they'll put their wrapper on it. But they're all sort of interchangeable. So at first, well, some of the limits for cameras, there are quite a few, right, is the light coming in. And that's ultimately the biggest one, is how much light you're getting in, and that decides how fast you can go, how clear the image is. All this stuff requires that. So you can fix a lot of that with your lens sensor combo. And so depending on what you're doing, if you're doing like really high speed, you need a lot of light coming in. And sometimes that even requires adding additional lighting for what you're doing. There's also there's varying different types of sensors. So depending on the sensor you have, it'll change how fast it can react. So sometimes you'll have, I guess there'll be bigger pixels, we'll say, which are physically capable of taking in more light so they can be quicker. There's processing done on the camera. So depending on how much processing, that also adds some time in what you're doing. And then one of the biggest ones is the bandwidth out of cameras. And that's the one that you don't really think about, but like basically the pipe off the sensor is what limits frame rate and resolution the most. And so USB 3 is fairly fast, and you can get ideally 5 gigs, GigE's a gig, 10. Camera link it's this sort of weird R&D type of interface, and you can sort of expand it. So a single camera link I think is actually 2 gigs, but most commonly you'll see 6, and then you can sort of double, triple up until you hit 72. Coax Express, same thing. I think 4 Coax Express lines will get you 25. So something to keep in mind when you're doing computer imaging is it's not the same as taking a picture. It doesn't work great if you have a really high count, like off your phone. That's a lot of detail. You really want something simpler, more refined to the task you're doing. So often black and white's a little easier. You don't have to like convert it. If you like, so you can take color and convert it to black and white, sure enough. But you can also just buy a sensor that's black and white. So that's one less step you have to do after it gets to you. And you don't want the extra data either, because that's, again, one more step up. So if you have a big frame, you only care about a small bit, it'd be easier to have a small frame. So why not use a webcam? Well, there's a lot of sort of downsides to them. One, your resolution is what it is. A lot of times I guess you'll get 1080p, but it's not going to be bigger and it won't be smaller. It's just going to be what you get. Same frame rate, like you can't speed it up or slow it down. It's the camera has a clock that says, okay, send a frame, send a frame. That is what it is. USBs only, which is fine if it's right here, but if I want to put it 200 feet that way, it'd be nice if it's giggy. Color only, again, you can convert it, but you have to convert it. It doesn't come off the sensor that way. And the sensors are small. I mean, they're relative, but you can have easily 6 times the area for light to hit on a different type of sensor versus what this is similar to might be what you find in an old cell phone. There's no trigger signal, so it has that clock, and at some arbitrary time says take a picture, but you don't get to say when that time is. And so for that, it's one of those, if you have multiple together, if you're doing something fast enough, it's important that they sync or you'll have some offsets there. And then there's also, the lens options are what they are. So you don't get to zoom in, you don't get a wide one, you just get what comes on that camera. There are some good things. They're real cheap. And they're easy to find, right? So you can find a webcam, I mean, probably on your laptop. You can get there. And it's good for just quick like doing things. But if you want to have a little bit more detail of a solution, you sort of have to go up a low. The cool thing about these is they have all the configurations. So resolution, depending on your sensor, that'll be what it is. But you can get big sensors. So you can get your 5, your 10, your 50 megapixel sensors. Those are sort of an option. Frame rate, same thing. You can say, okay, 30 is fine, and all these are compromises. Big resolution, you don't get the fastest frame rate. You can slow down the resolution, you can speed up the frame rate. So you can sort of turn those knobs as you need. Region of interest is an interesting one. You can have a big sensor. So let's say it's, I don't know, 5 megapixels, but I only care about 200 megapixels by 200. I can move that small little area within that sensor, frame by frame. So you can move within a big area really fast without having to physically move anything. And so like for that region of interest, this, I think, like all standard defaults, it's like 90 frames, I'll just tell you, 75 frames a second. The model numbers will give you sensor type, frame resolution, or frame rate by default, and color or black and white. But I can drop down the resolution and hit 500 frames per second. Bit depth is like how detailed of a description for 1 pixel do you need? Like, do you need, so basically it's how fine you say what level that pixel is at. Again, bit depth is another one of those things where the higher that is, the more detailed it is, but that's more data you have to transfer. Exposure time, it's like, okay, how long do I need the sensor to look and collect light and give me that data? Gain, it's, again, it's sort of, I got this value in, but I want to bump that up so that I can sort of arbitrarily get a good reading. Trigger signal is, okay, you can say internal clock just roll. It'll take picture, 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 or you can say, wait till I say go, and then take one. And then, and that could both be software, so you send a trigger signal, or it could be, you'll see a lot of these have these ports in the back, and that could be an external trigger source. And then sensor syncing sort of goes hand in hand with that, where you can say, I have 3 cameras, I want you all to take a picture when you get this signal. So there's some things to watch out for. They have some of these, like this one here, they have this weird M something connector, and you have to get a power supply for it. This one needs power. These are PoE, but so sometimes you'll have these weird connectors, and these are gig-y, but then there's camera link and other ones, again, strange connectors. You might need a weird capture card to use them. They're pretty power hungry. I mean, I can plug these in, they'll sort of sit here and get hot. There isn't focus. I mean, you'll see all lenses are all sort of manual. I don't think I've seen, I'm sure someone makes one, but again, these aren't really aimed at photography. They don't put out just a stream. You have to basically write some software to go collect and say, okay, instead of just look at this address, it's go out to this address and pull it, and then you modify it, and you can put out a stream from that, but it's just not by default. There's some libraries, the Pylon one's actually really good to do that. And then, yeah, if you have a camera link, for instance, you'll need a special camera link card because your laptop doesn't have a camera link input. And then there's the big one. These are not cheap. So, yep, that's 2,300. That's 509. And they also don't really want to sell to you because you're just a person. You're not a factory. You're not buying 12. You just want one. And so it's a little bit of a pain to get stuff. And they also, if I had an issue with this, they're gonna say, okay, what's your order number? And if I don't have that, they're gonna say, well, we can help you, but there's a fee. And so for firmware, stuff like that, you probably aren't gonna get much luck. Some of them work with you. I've dealt with a couple of guys, or like customer service guys, who are helpful, but in general, they're there for making money. And you're buying the camera. Like, when you buy one of these, you get this. And so you don't get cables, you don't get, even, you see how these are on a tripod? Yeah, you don't get that. There's no tripod mount in the camera, you're getting a sensor. And so you don't get a lens or cables, any of the accessories. And so that's something where it's like, well, at this point, it's like, well, who's gonna spend $2,300? Well, there's one good thing though. On eBay, they are very cheap. Yesterday, I looked, there are 95,000 of these on eBay. And a lot of them will have a lens. Like right here, this one up top is $80, it has a lens. Some of them will have cables, some of them have lights and mounts. And so for what I've bought, let's see, one thing to watch out for is it's an eBay listing for something, and you got to really look at what you're buying because often they'll be mislabeled, they want the right specs on there, but sometimes you get pretty good deals. So I bought 2 of these for $150, and the MSRP is $509 each, and so that's a fairly good deal. And then this one, that $2,300 one, I paid $123 for, or $27. So 95% off, or it's not bad for what you're getting. And there is that caveat though, you gotta know what you're buying, because I bought this because I looked it up and I was like, well, that's an incredible deal. And then I was like, I bought it, and then I was like, oh, I don't have that power cable. So there is a little bit of an asterisk, so if there was another 50 bucks to get this thing to turn on, but it's still a pretty good deal. And so that got me to sort of looking into why are they so cheap.
Theft.
Well, so what happens is if you have a product and you go to a factory to make it, they'll say, okay, well, that'll be, we'll say $20 a piece off the line. You're going to pay us $350,000 to set up the line for you. And so they buy a bunch of these for their line. They set them up, they get everything tailored to your product, and they start rolling off things. So as soon as you've paid them. They've already bought these brand new. They've made their profit. People install them, made their profit. Your products are going. And at some point, your products stop going, though. And when that changes, they're stuck with a bunch of specialized things for your product that you're not paying them for anymore. So they don't care. They made their money the day you signed up the line and bought them for them. So now they pull them out. It's not worth holding on to these things. They're specialized equipment. They take up space. You don't want to track a bunch of stuff that you don't really care about. So it's not worth doing anything with but getting rid of. And so, because they're in the business of producing products, they're not in the business of holding on to cool sensors. They have their purpose, and so they remove them. And more particularly, they tell some tech, hey, take off these lines and put in the new ones, get rid of those old ones. And the tech takes those home, which are bought on eBay. But the tech, he didn't buy them. He's getting rid of them like he was told, and so as soon as he sells them, it's 100% profit. So there's 95,000 on eBay, so he has to be competitive, so they start low, and there's a lot, and so they end up going real low. So if you're going to go down this route, there's some things to consider, sort of the specs to look at. And so we see most everyone thinks camera, they think sensor size, megapixels, and that's the end all be all. And it's important, but it's not the only thing there. So you do have the megapixels, as well as the sort of the physical size of that sensor. So there's that. There's the interface, going back to what kind of data comes in and out, the trigger type of signals, if it needs external power, the lens selection, because they're not going to come with a lens most likely, although when they're used, they most likely will. Because again, the guy pulled it off the line, it had the lens on it. Well, he's not going to sell two things if he can just put it in a box and be done. So the lens selection is different than if you go buy a DSLR. You know, there's a difference between like a full frame and a crop sensor. It's like that, sort of on steroids. There's a lot of sensor sizes, so 30 millimeter or 35 millimeters means very different things at different sensor sizes. And so there's a couple of calculators to figure out sort of the equivalency. Or you can do like this and just buy a zoom and sort of cover it. There's things to look at for external power, because again, like this one, it won't turn on off of just PoE. Another one's that how's it mount. So I've 3D printed some mounts like this one, but they're these little tiny M3 screws that actually mount to the bottom. So if you want to get to 1/4-20 tripod mount, you have to have some adapter plate there. IP rating, if you're doing something where it could be wet or outdoors, important to keep that in mind too. There's some neat things you can do with these though. So this is a line scan camera, which means it's a 8K sensor, I think. Good. No, 12K sensor. So 12K sensor, 1 pixel high. So there's 12,000 pixels in a line, but this does mean it can run at tens of thousands of frames per second. So you could have that watching a line and tell you exactly when something crosses that. There's high-speed tracking, that region of interest I was telling you guys about earlier with the big sensor, but you just take a small bit. You can have that small bit move at incredible speed and high frame rate because you're not moving all the data in the sensor, you're moving a small region of it. Multiple camera 3D scanning. If you are syncing the signals so you get the same thing at the same time, you can have pretty reliable sources of two different sides of the same object, which is sort of how you get 3D scanning. They make these in near IR ranges, so with an additional IR illuminator, you can get pretty good night vision. One of the neat things we did, I showed you that camera gimbal earlier. You can hook up a laser pointer to that, or anything that's moving, and put a dot far away, zoom in on that dot, and see motion of the dot, which is a magnification of motion at the thing moving. So, and then here's some links. there's a bunch of manufacturers. I've bought almost all these Basler cameras. I like their website because you have a pretty easy way to go through and see the different type of sensors, the interfaces, all this, and sort of figure out their cheat code of a model number system. This is a great one for figuring out that lens to sensor size. And then thank you guys for sitting through, and Dickie is going to answer all the questions. Or I can answer some if anyone has.
No, I got it.
Okay.
No questions. Good.
Dickie, does the Giggy, is it an RJ45 connector, or is it like a
Yep.
special?
Yep. It's,
Sir. Well, go ahead. Well, yes. So, I don't know. I had my own question that I can't ask myself.
You can ask me.
Okay. So you have these links open on one monitor and eBay open on the other, right?
So you like bounce back and like.
Yeah. Like what model?
yeah. So what I normally do is I would go through like their website and figure out what I want, and then each of their cameras. So like this is a ACA 2500-14 GM. ACA 2500 is the sensor. The 14 is the frames per second. GM is monotone. So you sort of figure out what you're looking for, and then sort of back off of that a little bit and see what is available. And so sort of put in that wild card of, okay, anything of this sensor type is what I'm interested in. Or you go the other way, and like if you're looking for a lens, you find the right lens, you figure out if it's the right sensor size. And there's a lot of equivalency. There's like most of the sensors I think are Sony, but there's some other options too. And there's one of those ones where you sort of look around and figure out price range, what you're looking for in the end, and work your way backwards.
Would these be suitable devices for like a DIY home security system?
Yeah, they certainly could be. There is the power aspect of it. I haven't measured how much they draw. I do know they get warm. So I don't know about that aspect. The Giggy aspect is nice, right? Like you can run one line and get your power, and you can have a lot of options as far as lenses, which is another one where, especially if you want sort of a longer range thing, it's a little tough to find that sometimes in a camera. So that's a nice aspect. And the IR or near IR band, if you're going to do night, helps a lot too.
Is the Giggy standard like power over Ethernet or the same pinouts?
Yep, you can plug it into a network switch and get to it on your network right next to your computer.
Perfect. Across that Giggy interface, is that just like a web server on the other side, or is it just a random 4K?
It is, well, I don't know all the details. You give it an address, you can, so you can reach out to these. They have basically a host computer smarts on here where you set the settings, you can set its IP address, you do all that, and then after that, when you go back in, so there's the sort of configuration side, but then when you want to just pull the stream, you basically give it an address to pull that stream in whatever that Giggy video format is.
So once you've got images coming off the camera, what's the next step then? Like you're doing process control and I've identified, or I've got a string here of products moving through a conveyor belt.
Yep.
How do I go from I've got a picture to that one is going?
So the quick and easy answer for all that is OpenCV.
Okay.
It's sort of the default how you modify or you do any video processing that's you're looking for differences, you're trying to identify stuff, all that is OpenCV is a very big sort of tool set for all of the image processing side. You can do it yourself, like there's hard ways, but that's the way I would start.
OpenCV is the hard one. There is no easy button. That's what I'm saying.
It's not too bad now. The Python side of it is not too bad. All right. Any more questions? All right. Appreciate it.